Hello, today we'll learn how to use Altium Designer. So this tutorial will cover everything you need to know from start to finish, even for beginners. So we will learn how to create libraries, how to create footprints, how to create your first project at circuit and PCB design, uh, use rules, define layer stacks, and so on. After that, some of the routing tricks, how to use pouring, how to use nets, and so on. And after that, we will learn how to export your PCB design to Gerbers and upload it to Osh Park or something like that. So today we are going to make complete circuit from components we built. So I will show how to make one component, and after that I will use my own library that I'll provide for you. So let's get started. Okay, so first thing to do is to create a component inside your library, because you need to have library in order to work with the Altium Designer. So let's make it. Okay, so we select library and schematic library, and after that we will select create library file new PCB library. Okay, so first thing to do, you will just go to defines and make our library friendly to our units. I usually like to use metric, and everything will be fine. Okay, so first we will go here into schematic library, double click on component if you want to use. Okay, so first thing to do is the default designator. You need to use, like, you can use anything, but put question mark after that. So U will be like chips, Q will be for transistors, J for connectors, R for resistors, C for capacitors. Like if capacitor it will be like here, this like connector will be J question mark. And okay, we are making an NE555 timer, so we will use a question mark. So this, what is this description? Is 555 timer, and this is a component basically name 555. Let's go and 555. Okay, so we need to add pins. So first thing to do is we know that we have 8 pins. Okay. Usually everything you should make everything into the grid 2.54 or 0.1 inch. Okay, if we press Control and left click, I mean Shift and left mouse button, it will increment. So okay, so we make six pins. Okay, we need to know basically one thing. We need to match a designator with a footprint. And name can be anything. So first name, if I remember, will be ground. This one will be trigger. This one will be out. This one will be reset. Now, if we want to have like a roof over the air, I don't know how it's called. We just put backslash like this. Okay. And of course we can rotate this pin if we want to, but so far so good. Let's see if I'm right. Let's go. Okay, here. Okay, so okay, reset. Cont, not south. Cont. Like this. This will be VCC. Discharge and threshold. Okay. What I like to usually do is to use a rectangle, so it will look like component. We will make it transparent because we want to see text. Okay, so next thing to do is, okay, so we created component. There's another trick. That's like op amp. If we have op amp, like it's created from 2 parts, there is op amp A and op amp B inside one package. We can make tools, new parts. So basically, it will create 2 parts, and we just need to match same idea. Create component. Just we don't need to double pins. Like if ground, you just make it on one part. You don't need to use ground for the second part. But you should have power supply defined in some of these parts. Okay, so we created first component. Let's make a library. Let's delete it. Okay. Okay, so after that we need to create PCB. So we need to create SO8, like SO8. And we can do that there is a component wizard that's also useful. Basically, it can create many components. Okay, so what is the part size? Usually we can find this in datasheet. Okay, here. Okay, so part size is 0.6, 0.6, and so first thing to do is create new project. So let's go to the project. Let's use default. First PCB. That will look okay. Okay, press OK. Now we need to add a schematic, and also we need to add PCB. And we should save it. PCB1 and sheet 1. Okay, first thing to do, well, usually I like to delete like borders and so on. If you need to use larger, you can select it here. So we have clear sheet. Okay, so we need to install libraries. I already show how to do it. If we can't find our libraries, we select libraries and again install it. Okay, so let's make it a simple 555 timer blinking LED. So let's go timer. It will be 555. Okay. So basically, this is a component we created earlier. Well, let's. We need also connectors like connectors. I will link this PCB, not PCB, this library to you, so you can use it. Okay, let's select. Okay, so if you want to rotate it, we select, we press space. Okay, even if you want to make it mirror, press X or press Y. Okay, so first we need to add nets. Nets are, well, not nets, that's called nets. Nets is simple wires. So we need to, so each net that will be called ground, it will be connected with other grounds. So like this. Also, we can use, we don't need to use these. These are just to make it simple and nice. We can use nets like this. If we make it threshold and we copy that here, these pins will be connected together. So we don't need to make like this loop. Okay, now if we press shift and left button of mouse, it will be copy wherever you are trying to grab it. So let's make it like this. So we need to add capacitor for just good measure. Decoupling capacitor like this. Again, it will be connected this one with this one with this. Okay, we need to get two resistors. I have multiple sizes. And basically, in library, if you create more components and just add footprints, it will show up here. So basically, you just need to match. As you can see, all my resistors will have on top 1 and on bottom 2. So all the nets are the same because component leg is net 1. I mean designator 1 and designator 2. So this is how you make it. Okay, we need to do like this. Okay, this. I don't. I'm doing this from my head. I don't know. Will it work? But whatever. This is just for testing. And As you can see, this will be connected with this one. The nanofarads here. Of course, we don't need it, but it's for good measure, usually. And also, you can edit, basically add parameters as you go along, like voltage rating and so on, size. Okay, reset will be connected with VCC, and output will be connected to LED. Go to LED, like this. Big resistor, like this. Again, if you press Shift and select component, it will copy and make like, you can make it like out, and of course we can make it like this. Basically, if net has the same name, it will be connected. Okay, so alright, we have simple design. I think it should work, so we are happy. All the values are, well, correct. So we need to annotate schematics because each component needs to have its own designator, like this, and it will be named like C1. That will be C2. This is a resistor, will be 1, 2, and 3, something like that. It will annotating from top to the bottom. So you want to annotate? Yes. So as you can see, C1, C2, C3, R3, and 1, U1. Okay, so we have circuit. Okay, now first thing to do usually is to take care of your board, and okay, so first thing to do is basically go to the rules, but at least what I like to do. Okay, so first you need to know only a few rules. What is the clearance? Usually I'm using 0.2. It will work basically for any manufacturer. Width, okay, smallest of usually 0.2. I don't like use it. I usually like 0.3 and like 5. Okay, apply. Okay, so routing VS. This is important. So let's go to the Osh Park. Design submission guidelines. Okay, so 6 mil trace, 6 mil. Okay, what is 6 mil? I don't like 6 mil millimeters. So I put 0.2. So basically you can go as low as this number. Okay, minimal spacing. Again, spacing is here. Clearance. Width is here. 0.2. Again, minimal dress-out. 0.33. 30. Okay, let's copy it. Routing VS. Where is it? Okay, so smallest hole is like this. Maximum it will be like 6. Predefined, just use it. Okay, now minimum diameter, I know already from my memory. Minimum, maximum, it can be anything. 0.7. Okay. Second thing, solder mask expansion. Usually I like to use 0. Pace expansion, again 0. Now this is the Polygon connect style. Basically, when you pour it, basically making one solid copper plane, it will make what's called thermal relief connect. So basically you can solder it without too much problem. If you have 4 layers and you don't put thermal reliefs, basically it's very hard to solder. You need to preheat your board, and it sucks. I made this mistake quite recent. Okay, so 0.5, that's okay. Later I will show how to disable thermal reliefs. Okay. Second thing to do is we need to go to the projects and remove rooms. It's not for today's tutorial. What's rooms? Basically, rooms, if you have multiple circuits and inside one basically one project, it will create rooms with the different parts of your circuit, and you can work and copy designer and so on. You don't need that. Okay, let's go to the board options. I like to use this is my preference. I like to use grid size like this and distance like okay. So we need to make a board outline. Oh no, first we need to make a layer stack. So layer stack is how your PCB is assembled. So how thick is the core, how thick is the copper, and so on. You can find again on the Altium. Not Altium, on the Osh Park or any other. Let's go to layer stack up, and it will show. Okay, so this will be the stack up. So this is what we need to match. 60 mil copper. Okay, if you press Ctrl and Q, it will toggle between imperial and metric. Because it is metric, imperial, just use imperial, and it will be 1. It will be 1. If we want to use like 4 layers, we just add layer, and it will add. And we press mark here, add layer, and it will create a 4-layer board, but we don't need it. Okay, go to 60. No. Okay, so board thickness will be 0.6. That sounds okay. Okay. After that, we need to define our board area. So we use a keep out layer. We must use keep out layer, or it is a good practice. Just one more thing, we need to add origin. It just makes life a little easier. Okay, just so press line. I like to use 0.05. Let's make it double click, like 30 millimeters long. We'll copy like this, and like this. Okay, so we select it and design board shape, define from select option. So it created a very small PCB. It should be enough. So when we rename all the components, we need to add them. Just press design, important changes, and basically, as you can see, we added a few components. Now, if we add a name, if we add a net name ourselves, it will be like VCC. And if we don't add net name, it will be like net resistor first, leg first. So if you don't want that resistor first, you can add like discharge. If you add it, you can do that. It will design import. It will make this pin discharge, called discharge. As you can see, rename this net to this. I usually like to press validate and then execute, and everything must be done. Green check marks. Okay, as you can see, discharge. I also don't like designators console screen. If you want to remove all of your designators, just press right click, find similar objects, designator same, top overlay same. Okay, so open this window and you press hide. So you are going to see. And this is, if you press number 3, it will show 3D model. Okay, so let's make it, just make PCB. So it was 6.5, it will be on the middle. Now, what is this? Basically, it says if we have some this cross marks, it means something is too close. So basically, our part is too close to the board edge. So let's just back it up. Okay. Now put our chip again. Yes. Oh, as you can see, we have very small resistor because I didn't show the. I just take it and did not select correct footprint. So let's see this one and this one. This is good, and I think this one. Okay, so if you make changes, just save it and design import. It will modify size. Okay, now it's much more workable. I usually like to use 06 or 03 components. And these short lines show what pins should be connected. Also, if you press Control and press on the pad, it will highlight pads that connected to the same net. And if we go to the mask level, we can make it like much more presentative. Okay, so let's make design. So we need to take these parts, put in here. So discharge. Okay, this is going to ground. We press this one. If we use tab, it will make it will show defaults. Okay, like this. I need to add. Okay, out goes to here. I usually because grid is 4 steps and each step is 0.025. This is if we see 3, it will be 3 multiplied by 0.1 millimeters. It's very it's basically I like to use this grid. It will show it's very easy to understand how far each component is. Okay, so we just discharge. We need capacitor to ground. Let's put it here. I usually like to line up everything very correctly. Of course, one thing, my library is always going to the grid for 0.025. Even imperial components, I just make them to fit. And that is not necessary, but I have OCD, or I should say CDO. Okay. I know that it's a little bit boring, but this is a real. This is I just want to make video from start to finish without any interruptions, so you will know you will know what you expect when you're making your own boards. Okay. It will be not very good PCB, but it will be PCB. Okay. Okay. Let's connect discharge with discharge. This one connected this, and let's make it like this. Okay. Okay, we need to connect this with this and this. Okay. And last thing to do is use via. Via is going to be on here. Via is just a going from one layer to the other. 0.7, 0.3. Okay, and we just copy this via and place it like here. We will delete it, and we go to the bottom layer. Again, we select it and we wrote it. And okay, so basically right now all of my nets are matched. All of my nets are connected except for ground. And what I like to do is press Tools, Polygon Manager, from board outline. Go select ground. You can connect it to any net. Top layer. I usually like to put very small number here, so it will track arc very nicely. Press OK, and create second polygon on the bottom side. Okay. Yes. Okay. Also, let's go layer set, signal layers, hide, add, source code. Okay, so as you can see, it created a polygon pores. As you can see, these are called these connections are called thermal relief. So basically, you can solder it, and heat will not going to flow to the PCB. These two pins are not connected because they don't have copper. Okay, so how can we fix that? Well, it should. Okay, so what you need to do, we can add also, I like to do add via stitching. Via stitching is basically going to stitch your board. You need to make 2 millimeters, 0.3302. Okay, basically it will generate vias. Let's see it, how it looks. Okay, so it looks quite nice. We don't have anything on bottom. Let's just make one something on bottom. Go layers, bottom overlay, make like string on the bottom overlay, mirror, test. Anyway, test. Okay. Okay, so it's test. Okay. Well, this is very nice looking PCB. Okay, so what I need to explain for you a bit more. If you want to, if we don't like thermal relief, we can delete it. So how we can do it? We go to the rules, design rules. We need to create a Polygon connect new rule. Like, let's make it direct. Okay, so direct. Now we can make in component like J1. So apply. Okay, so when we repur it, repur all, as you can see, connector is now flooded with copper. It is good and bad practice, so I don't know. And of course, vias also have thermal reliefs. I don't like that. So let's fix it. Again, same design, same idea. We can use logic. So we use or is via. Okay. So if we report it, tools, polygon pores, report all. As you can see, now it's nice. And of course, let's add it like C1. Also make it for C1 rules, or in component C1. Okay. Okay. Design rule, and not rules. Report design. Report all. And as you can see now, this component is also connected. So, and one more thing, just to make it complete. If, example, VCC is very high voltage, like 12 volts. We don't want to use this voltage with very small gaps. So we will create new rule, clearance, like call it high voltage. So make it like 0.35. So, and it will go to this. Basically, it says where some rules are validated, and it says it's too small. So let's go to tools, polygon pores, report all, and it will report it. And of course, it also says that it's again, and let's report all. Okay, so as you can see, this is how I do it, and we can also add, this is just make it a bit nicer, teardrops. Teardrops basically will make teardrops on each node. It will help with copper manufacturing process. Again, design, because we created shapes, we need to again report all, and that's it. And as you can see, well, one pin is. Anyway, so we created first PCB design. So let's generate Gerbers. So how can we do that? Again, go to the add project. I like to use output job file. Let's save it. Save. We select a folder structure, and add fabrication outputs. So you need to use NC drills and Gerber files. Now NC drills are basically default. I don't touch it. It works for me. If it doesn't work for you, just look at these settings from my. Okay, but Gerber files we need to select. So basically what we need top overlay, top paste, top solder, top layer, bottom layer, and keep out layer. If you have internal planes, add those also, like inner layer 1, inner layer 2. And you need to add keep out layer. Basically this is board outline, so this will be cut with routing tool. Okay, and we select we highlight this and select and generate. Okay, that's all. Let's go to Explore. Output, we select a drill file, and we delete this. Well, this is just unnecessary information. Yes, and so we have drill files. Bottom layer, well, you can read what it does, and we need to not rar it but zip it. Well, I don't know why, it just. So let's copy. Okay, let's go to the Osh Park. We are already here, so let's get started, and we need to select Gerbers. Okay, test. I should be logged in. Yeah, that's nice. Okay, so it's processing, and it's processing. Okay, so what else should I tell you? Well, basically this is how I do it. But there's also differential routing. You can use I also like to use polygons, like and I don't know. This is just tutorial to start up. Still processing. Okay. What else I can say about rules? Well, basically clearance. You need to know clearance, width, expansion. Maybe you need to correct it, and polygons connect. How they interacting. Also, you can use differential routing. Basically, you just need to define that you have a diff pair. This is for another tutorial. I will not go into cover. Oh, come on. So let's save it. Oh, okay. While it's uploading, let's add more layers, like layer stack manager. We'll add inner layer 1, and we will add here inner layer 2. Okay. So if we press it now, we will find signal layer 1, signal layer 2. If we go to the output job, Gerber files, we will add these two. As you can see, everything else is by default. You can also generate 3D models, like documents output 3D PDF. You can generate it. It will just create 3D model, and I like it very much. The tools, rotate it. As you can see, it's very nice. I like how it makes. And you can see we add layers, more layers, so it shows up. Okay, so what's the problem? Design. Bottom solder mask. Basically, what it means, I have nothing to solder on the bottom, so that's correct. So we just let them continue. Now continue. Please work. Come on, you can do it. Well, it will go and show all of your layers and so on. And if everything looks correct, yeah, you just order it. Um, uh, okay, so something is wrong with this website. Maybe it's too much. It's too heavily loaded. Let's try it again. Test. So it's very simple design, very good software to work with. And of course, I will create a PCB with all the maybe I can make PCB with all the rules, so you just include to your project, and you don't need to worry about Osh Park parameters. Like basically, if you want to use Osh Park for layers, so you need to you will find that the clearance is much better, and routing vias can be much more smaller. I think for full layers will be 0.2.4, like this. Okay, and okay, so okay, continue. Oh, finally. So it just show board top, board bottom. So drills, top full screen, bottom copper, bottom full screen, top copper, top solder mask, and board outline. Approve. Let's see. So if you order this board, it will going to cost $1.75. So this is very cheap, and you will get 3 copies. I like Osh Park very much for this. Basically, for small boards, it's very cost efficient. If boards is larger, it starts to suck. Okay, so thank you for watching this video. I hope it was clear, and you will be able to make your own PCB design in the software, because it helps. Oh, one more thing. Design rule check. Usually we just make design rules check. So basically what we don't want to see are nets, unconnected nets. Clearance will be just clearance. You can edit it in rules, but it will going to make as it is on the Osh Park, no problems. So thank you for watching, and I hope you will design your boards from now in Altium Designer. So thank you and have a good day.